Yeah. Have you tried solving this problem like one which I have given today? Okay. So let me discuss this problem. Like, what is the answer like this? So here I have declared a module called ex underscore 2, and I have declared four registers and one wire. This register is of 4 bits, this is of 5, and this is of 1 bit, and this is of 8, and this is of 1 bit. Now within an initial beginning block, I have assigned A is equal to 4 tick binary 0001 and C is equal to 5 tick binary x0. So the first question is, what is the value of A of 0? So the first question is the value of A of 0. Wait a minute. So here I have asked what is the value of A of 0. So I have declared A as a register which is starting from 0 to 3. So 0 is the MSB and 3 is the LSB. So A of 0 means I am asking MSB. So here the MSB is 0. So the answer should be 0. So this is the answer for the question 1. And coming to question 2, what is the value of A? It is simple and direct, which is equal to 0001. And coming to question 3, the value of C. I'm asking the value of C. Here I have declared C is equal to 5 tick binary x0. So it should be 0 x followed by 3x. 1, 2, 3. So the x will be appended. Since the MSB is unknown, here the MSB is unknown, so the MSB will be appended here also in the 3 bits. So the answer for the question 3 will be 4x0. And here I have asked what is the value of E. It is straightforward, which is equal to 1000. And I have asked the value of D, which is equal to, this is also a straightforward question, I think. What is, wait a minute, I haven't declared any D. I think I have declared, yeah, sorry. Here I have declared wire D. So D is a wire. So I'm asking what is the value of D. So it is equal to 0. If I haven't declared D is equal to 0 in starting, then what is the value of D? Then value of D will be equal to unknown. If I if I haven't declared D is equal to 0, then it is equal to unknown. So this is the answers for first 5 questions. And coming to, sorry, it should be 6th question. Here I have declared a string register. Here I have declared a register of string of 8-bit size, and I am assigning it to Verilog. So the value of this string, and I wanted to display the string. So the answer will be equal to G. Since string is of 8-bit, which means 1 byte. So I'm trying to store 1, 2, 3, 4, 5, 6, 7. That is 56 bits into an 8-bit register. So it will get uh, so only the LSB 8-bit will be stored in this string. That is, G will be stored and it will be displayed. So this is the day 4 of Verilog 108 day course. So in this lecture we will cover about integers, real numbers, time variables, and arrays. So let me take my pointer. So an integer is a general purpose register data type used for manipulating quantities. So an integer is like a general purpose register data type, and it is used for manipulating quantities. Integers are declared by the keyword integer. So if we want to declare an integer, we use the keyword integer for declaring any integer a. So a will become an integer data type. And integers are declared by the keyword integer. Although it is possible to use a reg as a general purpose variable, it is more convenient to declare an integer variable for purpose such as counting. So we can also use register data types, but integer is also used for, like, in the cases where we want counting to happen, we prefer using integers. So this is the introduction, and the default width of an integer and the default width of integer depends on simulator, but minimum should be 32 bit. So the default width for an integer is the host machine word size, which is implementation specific, but it is at least 32 bits. And the registers declared as data type reg store values as unsigned quantities, whereas integers store values as signed quantities. So for example, if a variable is declared as a register, for example reg b, and if we store any data into this register, then if any data is stored into this register variable b, then the data will be stored in the form of unsigned. The data is stored in unsigned form in this variable b. Whereas if we declare any variable as integer type, say suppose integer c, then if we try to store any data into the c, then the data will be stored in signed form. Remember the difference, this is very important. So if we declare any variable as a registered data type, and if we want to store any data in this registered variable, then the data will be stored in the form of unsigned. Whereas here, if we declare any variable as integer, and if we want to store any data into this integer variable, then the data will be stored in the form of signed. So this is the difference. And here the registers declared as data type reg store values unsigned quantities, whereas the integer store values as signed quantities. For example, here we can see they have declared a counter of integer data type, integer counter. So within an initial beginning block, we can simply assign counter is equal to -1. So this is so a negative number is directly stored in the integer. Whereas in case of registers, if we declare any register a, and if we want to try to store it a is equal to -1, then negative number is not stored in the register a, but the 2's complement will be performed on -1 and it will be stored in a. But whereas in case of integer, the negative number is directly stored in the variable. So this is about the integer. Is this clear for everyone? So coming to real numbers. So real number constants and real register data types are declared with the keyword real. They can be specified in decimal notation, example 3.14, or in scientific notation, example 3e6, which is equal to 3 into 10 power 6. For example, if we want to declare any real numbers, we will use the keyword real. So real is the keyword. If we want to declare any real numbers, then we will use the keyword real followed by the identifier name. A is of type real. So if we want to store any decimal number inside this real number, it is possible. For example, a is equal to 3.14, then this decimal number will be stored inside our identifier or variable a. For example, if we want to represent any scientific notation like 3 into 10 power 5, then we will represent as 3. Here we can see 3e6. Wait a minute. 3e5. Like this. If we want to represent 3 into 10 power 5, then we will represent as 3e5. Like this. If we want to store any fractional number or decimal number, then we will use real numbers, and for representing real numbers we will use the keyword real. So real numbers cannot have a range declaration and their default value is 0. It is also a very important interview point. What is the default value of a real number? So the default value of a real number is equal to 0. This is a very important point. So the default value of reg is equal to 0. The default value of wire is equal to high impedance. The default value of integer is equal to 0. And the default value of real number is equal to 0. So these are the questions which are asked in interviews. So what are this? They may shoot any of this question, like what is the default value of integer or what is the default value of real number, like that. So when a real value is assigned to an integer, the real number is rounded off to the nearest integer. So if a variable, say b, is declared as an integer, and let's say a real number c is declared as a real number, so if we assign c is equal to say 5.6, and if we want to assign b is equal to c, then the value of b will be equal to 6, since 5.6 will be rounded off to 6 and it will be stored into the integer. So this is how when a real number is so the sorry, so this is how when we want to assign a real number to an integer, this is the process. Here let's see an example. They have declared a variable called delta of type real. So let us declare a real variable delta, and within initial beginning block they are assigning delta is equal to 4e10, which is nothing but 4 into 10 power 10, and again they are assigning delta is equal to 2.13, and they are assigning integer I, and they are giving I is equal to delta. So what will be the value of I? So it is nothing but 2, since delta has a value of 2.13. The last updated value in delta is 2.13. This is the last updated value. So the 2.13 is the last updated value and it is stored in the delta. And if we want to assign a real number to an integer, then the value will be rounded off to the nearest integer, that is 2.13 is rounded off to 2. So the value of I will be finally equal to 2. So this is how when a real number is assigned to an integer number, this is a process how it happens. So is this clear for everyone? So now let's see about time variable. So Verilog simulation is done with respect to the simulation time. So our coding will happen with respect to simulation time. Our coding and our whole Verilog code will be executed according to the simulation time. So this is very very important, and a special time register data type is used in Verilog to store the simulation time. For example, if we inside a module, say this is some module followed by end module, and we have written some lines of code, this say this is line 1 and say this is line 2. So say some at 0 simulation time, this line 1 gets executed, and at say at 10 simulation time, this line 2 gets executed. We do not know what is inside it, but I'm taking a reference example. Say this is some simulation time and this is some time at line at 0 simulation excuse me. So at 0 simulation time, the line 1 is getting executed, and at 10 simulation time, the line 2 is getting executed. So for storing and displaying the time at which line 2 or line 1 is getting executed, we have a special type of register called time register. So this register will store the value of simulation time. It will store the value of simulation time, and we can also display this time by using this time register. So with the help of this time register, or we can display the simulation time. So a time variable is declared with the keyword time. So the keyword for the time is time, and the width of the time register data types is implementation specific. This is implementation specific, but it is at least 64 bits. So the default is depends upon the simulation, sorry, depends upon the implementation specific, but it is at least 64 bits. This is also a interview question. And the system function $time is invoked to get the current simulation time. So by using the $time, this is a system function. So using this system function, we will get the current simulation time. So here we can see an example. They have declared a variable called save underscore sim underscore time. So this is an identifier, and this is a keyword. So save underscore sim underscore time is of data type time, and within an initial beginning block we are assigning save underscore sim underscore time is equal to $time. So what happens here? Save underscore sim underscore time is equal to $time. So $time will return, will give value to save underscore sim underscore time. This value will be depends on the current simulation time, at which time this statement is executing. So that time will be stored in this save underscore sim underscore time, and if we display this save underscore sim underscore time, then we will get the time at which this assignment is getting happened. So we will see some examples in our future sessions. So for now, for now keep in mind that the $time will display the current simulation time at which it is provoked or invoked. So this is about the time variable in Verilog. So is there any doubt in this? Coming to value, reg is unknown and wire is high impedance. And coming to size, reg is by default 1 bit, wire is also 1 bit, and the default width of integer is 32 bit, and it depends upon the simulator, but minimum it should be 32 bit, and the default value of time also depends on the simulator, but the minimum width should be 64 bit. And the default value of integer is 0, and the default value of time is also 0. Sorry for the confusion. Is this clear?
Yeah, that's clear.
Thank you. So now coming to arrays. So arrays are allowed in Verilog for reg, integer, time and vector register data types. So arrays are not allowed for real variables. So we cannot use arrays for real variables. So arrays are accessed by array name followed by subscript. And in Verilog, we cannot use multi-dimensional arrays. So it is not permitted in Verilog. So for example, here we can declare an array of so here we have declared an integer count 0 to 7. So integer is a data type and count is a name of the array, and 0 to 7 is the size of the array. So we have an array of 8 locations, 1, 4, 5, 6, 7, and each location is of 32 bit. Since we are using an integer data type, so each location is of 32 bit, and we have 7 locations, 0, 1, 2, 3, 4, 5, 6, 7. So this is the name of the array is count. So this is the pictorial representation of the given array, integer count 0 to 7. And also we can declare of register type. Reg is the data type, bool is the name of the array, and 31 down to 0. So here if we want to represent it pictorially, then we have 31 locations, and each location is of 1 bit. Since we are using a reg and we are not mentioning the width of a location, we are just mentioning reg. So each location size is 1 bit, and we have 32 locations. So array of 32 1 bit boolean register variables. And here they have declared integer matrix 4 down to 0, 4 down to 0. So this is a multi-dimensional array which is not supported by Verilog. So this will throw an error. So this is a brief introduction about arrays. We will discuss more in our upcoming videos. So this is all about today's session. So if you have any particular doubt or any queries, you can ask. So that's all for today's session. Thank you.